Right, we have n, and it's an integer. Ooh, before we go on, what's an integer? Remember that an integer is a whole number. So 4, 5, 6, 7, 8, not a half or 3 halves or minus 2.5 or anything. So whole number could be negative, and it is such that, in other words, it satisfies or it works in this inequality, 3n plus 2 is less than or equal to 14, and this inequality, 6n over n squared plus 5 is greater than 1. And find all the possible values of n. Well, there's nothing for it. We've got two inequalities, and we need to solve them. So let's go with the first one. And that is 3n plus 2 is less than or equal to 14. Now this just looks a bit like an equation, and indeed for linear inequalities. Why do I mean linear? Well, look, there's no squared here, unlike the other one. So we just solve it like an equation. Get the term with n in it on its own by subtracting 2 from both sides, and that gives me 3n is less than or equal to 12, and then get the n on its own by dividing by 3. And of course on the left, the 3's cancel, which gives me n is less than or equal to 12 over 3, which is 4. So we know something about our integer, or the possible values of n, and that is that they are less than or equal to 4. So 4, 3, 2, 1, 0, minus 1, etc. But we need to solve the other inequality as well. This one here, 6n over n squared plus 5 is greater than 1. Now, how are we going to solve that? Well, it's a quadratic inequality, as we've said. So we're going to look in the blue box and see what it says. It says always, which means always. So we always do this. Factorise, well, hang on a second. It's not in the right form to factorise yet, because it's still in this sort of form here. So let's get it into the right form first, and then come back to the blue box. So how do we solve this one? Well, we get rid of fractions, and there is a thing on the bottom. So we multiply that. So we multiply the right-hand side by n squared plus 5, and we multiply the left-hand side by n squared plus 5 as well. And of course, as above, the whole point of multiplying or dividing or whatever is that something disappears. And I've got rid of the n squared plus 5's on the left, and I've just got 6n is greater than, well, 1 times n squared plus 5 is just n squared plus 5. Now, it's a quadratic, because it's got an n squared and an n and a number term. And with quadratics, well, look at the example in the blue box. I want to get everything on one side and have a 0 on the other. So let's do that by subtracting the 6n from both sides. And we get 0 on the left is bigger than n squared minus 6n plus 5, writing it in the traditional form of the squared, then the n, then the number term. Now then, go back to the example in the blue box. When I've got it in that sort of form, it says always factorise, so I've factorised it. Why do I factorise it? Well, it means I can sketch a graph. And look, what makes the bracket 0 in my example? Well, x equals minus 1 and x equals 5. So those are the roots of the graph. That's where it crosses the x-axis. And then once we've done that, we simply use the x-axis as a number line and read off the answers. I'll show you more about that in a second. Okay, so let's follow our rules. So we're going to factorise this. It's got an n and an n. And although we could go into more detail on this, I'm not going to go into too much detail. We need two numbers which multiply together to give plus 5 and add together to give minus 6. And a very small amount of thought tells me that that is minus 1 and minus 5. Okay, now sketch a graph of the left-hand bit. So I'm going to sketch a graph of y equals n minus 1 times n minus 5. Okay, so I've got some, let's do this in red. I've got some axes to put in, like this, and then my graph looks a bit like this, where that is 1 and that is 5, because as I said earlier, we're looking for things that make these brackets 0, and n equals 1 and n equals 5 are as it were, the critical values. Okay, we might even write that down. Critical values are n equals 1 and n equals 5. Okay, and they are the points on the graph where it crosses the axis. Okay, now, what do I mean by use the x-axis as a number line? Well, here we go. In fact, of course, it's the n-axis, but it comes to the same thing. What we're looking for is we're looking for places where this expression here, which expression? The one I'm just trying to rub out, this expression here, or indeed this one with the brackets, is less than 0. Okay, so we're looking for it to be less than 0. In other words, where it's below the axis, where the graph is below the axis. Where is it below the axis? Well, for these values of x here. Anything in between those 2 points. All points in between 1 and 5, the graph is below the axis. Notice that I haven't included 1 and 5, and I've indicated that by the open circles. And now, as I say, use it as a number line. Just read that off. Well, that's 1 is less than n is less than 5. And so n has to be between those two values. It also has to be, go back to here, less than or equal to 4. And from here, it has to be between 1 and 5. And so my only answers are, so n can be 2, 3, or 4. And that is that.